meters above the canyon floor, 2,051 feet straight down. That's twice the height of the Eiffel Tower, tall enough to literally touch the clouds. This is the Huajiang Canyon Bridge in China, the highest bridge in the world. But here's what makes it truly impossible. It spans 1,420 meters across one of the most dangerous gorges in western China, a V-shaped canyon. Fractured rock, hurricane-force winds, dense fog that forced previous projects to be abandoned before construction even began. How do you anchor cables into cracked mountain rock? How do you lift a highway deck 600+ meters into the air? How does it survive typhoon winds and earthquakes? This is the story of how China conquered the clouds. 1. The Earth's crack where this bridge lives. Welcome to Guizhou Province, southwest China. They call it the Museum of World Bridges. Geologists have another name for it, a nightmare. 92% of this land is mountains and deep gorges. The Earth's crust looks like it was smashed with a giant hammer. For centuries, this massive crack in the Earth has been a wall stopping everything. If you lived on one side and wanted to cross to the village you could see right across the gorge, you couldn't just walk over. You had to drive down a terrifying, twisting mountain road for 70 minutes, sometimes hours. One slip on those roads, game over. The Huajiang Canyon sits at the confluence of the Beipan River, a perilous gorge where the terrain is hostile and the weather is brutal. Dense layers of fog, winds that reach Beaufort level 14, hurricane strength. China needed a fix. They're building the massive G56 expressway to connect the rich East Coast to the borders of Southeast Asia. But this canyon was the final boss. The mission? Cut that 70-minute death drive down to just 60 seconds. Beyond speed, this bridge represents survival, emergency response, economic growth, logistics. This isn't just a bridge, it's a lifeline. 2. The engineering decision only suspension works. Engineers looked at every option. A beam bridge? No way. At this span, beam bridges fail. An arch bridge? Impossible. You'd need foundations in the canyon, but the terrain makes that impossible here. A cable-stayed bridge? It has limits. This configuration, combined with height and wind constraints, ruled it out. There was only one choice, a suspension bridge. Only suspension can span 1,420 meters while keeping the deck high and light. The numbers are staggering. Main span 1,420 meters. Total length 2,890 meters. Tower heights 262 meters and 205 meters. Steel truss deck weight 22,000 tons. But this wasn't going to be a normal suspension bridge. The ground here is treacherous, karst limestone. Rock that looks solid but is full of holes and cracks like Swiss cheese. If you put a heavy tower on it, the ground could literally crack open and swallow the bridge. 3. Foundations drilling into fractured mountain rock. Before anything else, engineers had to solve the foundation problem. The enemy, weathered karst rock, cracks, groundwater, landslide risk. The foundation of the bridge towers had to be drilled deep into layers of gas-stated rock, filled with fractures and underground water. The slightest error could lead to catastrophic failure. The solution? A special system of piles. 24 enormous concrete piles driven deep into the soil per side, combined with anti-seismic steel reinforcement. Think of it as creating artificial rock pillars. These piles don't just sit on the surface. They penetrate deep into stable layers beneath the fractured rock, transferring the tower's weight to solid ground. The timeline? 670 days from pile installation to tower concreting completion. Nearly 2 years of invisible work, all to ensure the towers wouldn't shift a millimeter. 4. Towers 2 skyscrapers on a cliff. With foundations secure, the next step, erect the towers. Tower 6 stands 262 meters tall. Tower 5 stands 205 meters. For perspective, that's taller than the Space Needle in Seattle. These aren't just tall, they're built directly on the edge of a cliff hundreds of meters above the canyon. The construction method? Climbing formwork with anchored cranes. Concrete was poured in sections. As each section cured, the formwork climbed upward, and the process repeated. Why must towers be overbuilt? Wind loads, traffic vibration, seismic loads. These towers don't just support the bridge, they must withstand forces that would topple ordinary structures. Together with the 2 giant cables weighing more than 9,000 tons each, these towers hold the bridge like 2 pillars holding a ribbon in the air. But towers are meaningless without anchors. So where do you tie a 9,000-ton cable? 5. The anchors: 1 concrete mountain, 1 tunnel. Anchorage does one thing. It holds the main cable pull. but the two sides of the canyon presented asymmetrical challenges. On the Zhenfeng side, the ground was flat enough. Engineers went with the brute force method, a gravity anchor block, 164,000 cubic meters of concrete, as big as 65 Olympic swimming pools. It's so heavy that not even a tornado could move it. But on the Guanling side, engineers had a problem. The cliff was too steep, no room for a massive concrete block. So they did something genius. They used the mountain itself. They carved an anchorage tunnel deep into the mountain. Instead of a large concrete block on the surface, they excavated into the slope and fixed the system directly into the natural rock. All the tension from the cables transfers into the mountain itself. This is brilliant engineering, using geography instead of fighting it. Now you have anchors, but how do you get the first line across a 1.4-kilometer void? 6. Catwalks plus first line across drones in a canyon. The temporary catwalk serves one purpose. Workers need a path to build the cables. But first, you need to get the pilot rope across the canyon. In the old days, they used helicopters or even rockets. But this is 2024. Engineers used drones. Heavy-lift drones flew the first pilot line across the 1,420-meter span, battling strong crosswinds. From that thin line, they pulled thicker and thicker cables until they built the catwalk, the temporary path suspended between the two towers. This process required precision and safety. One mistake, and the line could snap or drift off course, but it worked. The catwalk was formed, creating the foundation for the most critical phase, building the main cables. 7. Main cables, tens of thousands of wires. Now comes the real nightmare, spinning the main cables wire by wire. Each cable is formed by tens of thousands of high-strength steel wires, woven with extreme precision to support tens of thousands of tons of load. The specifics: each cable, 217 strands. Each strand, 91 wires. Wire diameter, 5.7 millimeters. Placement precision, error under 2 millimeters. Suspended on aerial catwalks hundreds of meters above the canyon, workers installed the cables wire by wire. Each wire was composed of 91 high-strength steel filaments, pulled between the two anchor points under GPS supervision, maintaining an error of less than 2 millimeters. Amid strong winds and hundreds of meters in the air, controlling each movement was crucial. Nearly 100 workers worked around the clock in rotating shifts. After installing all 217 strands, a specialized machine compacted them, forming a circular cable. Then the assembly received several protective layers to resist corrosion, weather, and vibration for decades. Fire safety was critical. The cables were engineered to survive temperatures up to 1,100 C for up to an hour in case of tanker accidents. Only after the completion of these two main cables could the bridge advance to the next stage, suspending the deck in the air. 8. Deck erection, 93 segments flown into place. With the two main cables completed, the bridge entered its decisive phase, suspending the deck. First, engineers installed vertical hangers, each one fixed to the main cable by specialized clamps capable of supporting thousands of tons. These hangers transfer the load from the deck to the main cables, then to the anchor points. Next, the bridge beam, composed of 93 steel segments, was hoisted one by one, starting from the center and advancing gradually to both sides. Each segment weighing hundreds of tons was lifted by pulley systems, suspended more than 600 meters above the water, and connected to the hangars by special load-bearing joints. Normal cranes don't work at this height. Instead, engineers used an intelligent cable hoisting system, pulleys and synchronized winches riding the main cables. Segments were lifted from below and guided into position. The construction logic: build from center outward symmetrically. During assembly, engineers constantly adjusted the sag of the cables, the tension of the hangers, and the position of each segment to keep the deck aligned, even under strong winds. Constant monitoring, sag, hanger tension, alignment, bolting and welding connections. After the installation of all 93 segments and their union into a single structure, the paving system was applied, transforming the suspended steel into a fully functional highway. 9. Survival-proof wind load, and the truck test. After construction completion, The next step, evaluate the bridge's real strength. In the load test conducted in August 2025, 96 heavy trucks with a total weight of 3,700 tons were used to assess the load capacity and dynamic performance of the bridge. More than 400 sensors recorded data on deformation, stress, and vibration, ensuring the bridge met the most rigorous safety standards. Engineers watched breathlessly. Did the deck bend? Did the cables stretch too much? The result? The bridge didn't just hold. It barely flinched. It was ready. But the biggest enemy remained: the wind. The Huajiang Canyon acts like a wind tunnel. Gusts can hit Beaufort level 14, hurricane strength. Safety protocols required stopping work whenever winds reached level 6 or higher. Work often began at 6 a.m. to catch calmer windows and frequently extended until nightfall. To fight the wind, engineers installed wind deflectors and stabilizing plates. They also used Doppler LiDAR wind mapping to forecast patterns and optimize construction timing. The test didn't just confirm safety, it demonstrated advances in real-time structural health monitoring. 10. The Why Human Impact plus Cloud CAF. After all the effort spent conquering mountains and cliffs, the bridge now opens a completely new world for this region. In the past, traveling from the bridge area to Guizhou City took at least 3 hours. Now it takes a maximum of 5 hours, saving almost half the time. Faster travel doesn't just make life more convenient for locals, it benefits thousands of others across the entire area. But China didn't just build a highway, they built a destination. As a combined transportation and tourism project, the Huajiang Bridge was designed from the planning phase to ensure both structural integrity and visitor experience. Right at the top of the bridge tower, 800 meters in the air, they built a glass bar and caf, the Interstellar Coffee Sky Caf. Yes, you can sip a latte while looking down at a drop that would make a skydiver sweat. There's also a glass bottom walkway under the road deck for adrenaline junkies, and a glass elevator descending 207 meters. It's not just infrastructure, it's an extreme sport, a viral destination. The bridge connects with the G56 expressway, reducing travel time and opening regional trade routes between China and Southeast Asia, attracting investment, creating jobs, and improving education, healthcare, and tourism. The Huajiang Canyon Bridge isn't just a giant engineering structure, it's the culmination of intelligence, effort, and perseverance of Chinese engineers. From the early days of drilling deep into the rock layer, pouring concrete for the main tower wells, completing the tower tops, installing the steel crossbeams, tensioning the suspension cables, and installing each locking component, each step was filled with challenges and required absolute precision. But zoom out. This isn't just one bridge. Guizhou is the bridge province, the Museum of World Bridges. Many of the world's highest bridges are here. The province has turned its geography from obstacle into advantage. The story of the Huajiang Bridge isn't just the story of a world record. It's a testament to the transformation of Guizhou province, from a remote, rugged land to one now integrated into the modern rhythm of the 21st century, 625 meters above the ground. Built for the people below. Welcome to the bridge that touches the clouds.